calculation on an empirical formula, and this is step 1. So this is a very straightforward one, Dr.
Good, glad to hear that.
Now the important thing is, when you do a calculation, you always must read the question properly and also extract information.
Okay, so we've got what is the empirical formula, so that's the first clues to what we're doing, of a compound containing 75 grams of carbon and 25 grams of hydrogen. So can you just remind me, Miss Karen, what is an empirical formula?
An empirical formula is the simplest ratio of the atoms of each element in a compound.
Okay, so from that I know that the first thing we need is the elements in the compound, and we've only got 2 elements here, which are, should we have a column for elements?
I think that's a good suggestion,
Okay.
Dr. Bourne. So we have, the first column would be element.
Okay, so elements, now let's have a look. What is the empirical formula of compound containing 75 grams? So carbon is our first element.
Carbon is the first one.
And the second one must be hydrogen.
Excellent, it's very straightforward.
Okay, and I can see that we have the mass of the carbon and the mass of the hydrogen. So should we have a column for the mass?
Another good suggestion from Dr. Bourne.
Okay,
So the mass of the carbon is 75 grams.
right.
The mass of the hydrogen is 25 grams.
Lovely. But, Miss McLaren, can we use the masses directly to work out the ratio of the elements?
No. From mass, we can calculate the number of moles, and it's from the number of moles of each of the atoms we work out the formula. Dr.
Right,
Bourne.
so it's the ratio of moles. So another column for moles.
Fabulous.
Moles. And we remember, I'm sure, from a previous video, that moles equals
Mass over the AR.
The
and we
AR.
use the AR, Dr. Bourne, but not the MR, purely because we're dealing with atoms.
But the AR is the number that we find on the periodic table, the bigger number on the periodic
That
table.
is correct.
Great, so I can look up, well, you previously looked up for me, on our whiteboard here, we can see that the AR of carbon is 12.
12.
So that
So,
goes,
great.
mass is 75
So it's 75 grams
over
divided by 12 grams.
12.
And that gives you...
What does that give us? 75 over 12? 6.25 in my head.
Right.
Great, let's go for that. You can use a calculator. Okay, and then we've got 25 over 1.
Well, now, can I do that calculation,
Yes,
Dr. Bourne?
yes, with no calculator for this one.
Great. 25.
Excellent. So far we've got a ratio of 25 to 6.25. So how do we work out the ratio of those two numbers?
Well, it's very straightforward. What you do is you look at the smallest number.
Okay, so we'll have a column for ratio. Should we
That's
move
it.
out of the way now?
So for the ratio, you look at the smallest number, you circle it, well I do anyway, and then you divide each of the numbers by the smallest number. So for example, Dr. Bourne, 6.25 divided by 6.25 gives you 1.
Anything divided by itself is 1, so there's always going to be
There's always going to be
with
1 as part of your ratio.
Okay, fine.
And then the second number, you have 25 divided by 6.25. And can you use your very up-to-date calculator, Dr. Bourne?
Now, if you haven't got one of these super duper things, 25 divided by 6.25 is 4.
4. See? All things do work. So we have 4.
So the ratio is 1 to 4, but finally we've got to have the formula. So what is the formula?
Well, that means you have 1 carbon and you have 4 hydrogens, which means your empirical formula is CH4. And make sure you include it in your answer.
Okay.
So it's
CH4.
CH4, otherwise known as methane.
Okay.
So, Dr. Bourne, I think that's...
Should we have a little quick recap so that we know we have the, write down the elements, the mass, we need to know the number of moles, then we divide by the smallest
smallest number
moles,
to work out the ratio.
the ratio. When we've got our whole number answer for that, we put it next to the relevant element to get the formula.
That is correct. So, job's done.
Job's done. Excellent.